Hello and welcome to another Mr. Marriott Maths video. This time we're tackling question 4 from Leeds Maths School Decision 1 Assessment number 7. We're told that figure 3 represents a network of tram tracks and the number on each edge represents the length in miles of a corresponding track. One day, Sarah wishes to travel from A to F, minimising the distance that she travels, and we're asked to use Dijkstra's algorithm to find the shortest path from A to F, stating the path and its length. So starting at A, so A has order of labelling 1 and final value 0. And now we're going to update all of the working values of vertices connected to A. And that's B, with working value 5. We're going to look for the vertex with the smallest working value, and that's currently B. So I'm going to label B second with final value 5. And all of the vertices connected to B are going to get a new working value. C is going to get working value 5 plus 17, which is 22. And E will get working value 5 plus 13, which is 18. I'm going to visit the vertex with the next smallest working value. That's E, so I'm labelling E third with final value 18. I'm going to update the working values of the vertices connected to E. 18 plus 21 is 39. 18 plus 31 is 49. And 18 plus 7 is 25. I'm going to visit the vertex with the next smallest working value. That's C, 22. So I'm visiting C fourth with final value 22. And I'm going to update the working values around C. 22 plus 15 is 37. I'm going to visit the vertex with the next smallest working value. That's K. I'm labelling K fifth with final value 25. And I'm going to update the working values of all the vertices around K. 25 plus 15 is 40. 25 plus 23 is 48. And 25 plus 17 is 42. I'm going to visit the vertex with the next smallest working value, and that's D with 37. I visited D sixth with final value 37, and I'm going to update the working values of the vertices around D, which don't yet have a final value. 37 plus 13 is 50. 37 plus 10 is 47. And that's it for now. I'm going to visit the vertex with the next smallest working value, and that's J. I'm labelling J 7th with final value 40. I'm going to update the working values of the vertices around J. 40 plus 9 is 49. 40 plus 14 is 54, which I'm going to disregard. And that's it. I'm going to visit the vertex with the next smallest working value. That's H. I'm going to visit H 8th with final value 42. And I'm going to update the working values of the vertices around H. 42 plus 4 is 46. I'm going to visit the vertex with the next smallest working value, and that's G. I'm visiting G 9th, and it's got final value 46. I'm going to update the working values around G. 46 plus 2 is 48. Last but not least, I'm going to visit the vertex with the next smallest working value. There's only one vertex left, that's F. I'm labelling it 10th with final value 48. So what is the length of the shortest path from A to F? Well, that's 48. I can look at the final value for F. I've now got to do my backtracking from F. So I'm going to put F last on the path, and I'm going to see where did I come from to get 48 at F. Well, 48 subtract 2 is 46, so I must have come from G. To get to G, I must have come from H. To get to H, I must have came from K. To have gotten to K, I must have come from E. To come from E, I must have come from B. And to have gotten to B, I must have come from A. So my shortest path is A, B, E, K, H, G, F with length 48. Where do the marks come from? Well, I get a method mark for having a larger value being replaced by a smaller value at least once in the working values at either D, F, or G. So D, F, or G, where I've replaced values. If I've replaced a large value with a smaller value, that's a method mark. And then my accuracy mark comes from having entirely correct boxes. So my first accuracy mark comes from having A, B, E, C, and K all correct. So these are the 5 vertices to begin with. There was no replacing values in these. We can condone a lack of 0 in A's working value because it didn't have a working value to begin with. But B must have a working value of 5. The second accuracy mark comes from having D, J, and H correct. And then the third accuracy mark, which is a follow-through mark, comes from having G and F correct. That means that if you made a mistake previously, but then followed from that mistake entirely correctly, you can get that mark. It's also important to note that you're only penalised for getting the order of labelling incorrect once. So if you use the same order of labelling multiple times, you're only penalised once for that. Last but not least, we're going to have an accuracy mark for the path, and the path needs to be correct, but there is a follow-through accuracy mark for the length of the shortest path, as long as it matches your final value at F. Okay, moving on to part B, and we're told that Sarah wishes to travel from A to F via J. We're asked to find a route of minimal length that goes from A to F via J and state its length. So, to do that, we first need to visit J. How are we going to visit J? Well, I'm going to go to J from K. So I must have come from K to go to J. To get to K, I must have came from E. To have gotten to E, I must have come from B. And to have gotten to B, I must have come from A. And then how am I going to get from J to F? Well, to get from J to F, I can either take this edge of length 9, or I can take edges of length 14 or 15. It's clearly going to be this 9 that takes me directly to F. What is the length of this path? Well, from A to J is 40, and then an additional 9 to get to F, so it has length 49. These two are independent accuracy marks. Okay, next up, we're asked to perform Prim's algorithm starting at G to find a minimum spanning tree for the network. So to do this, I would draw the vertices out again. You could try performing Prim's algorithm on a distance matrix, but you'd have to set up a distance matrix. And I'm going to start from G. What is the shortest edge that connects G to another vertex? That's going to be GF. And I should label my vertices as well. So I'll do that just now. So GF2. And after I've done that, I'm going to list GF. Okay. Next up, what is the shortest edge that connects a vertex not on my tree to my tree? That's going to be GH4. And I'm going to list it down, GH4. What's the shortest edge that connects a vertex not on my tree to a vertex that's on my tree? Well, I could do FJ. Doesn't seem to be many more. No, it's going to be FJ with length 9. Okay, next up, I'm going to find the shortest edge connecting a vertex not on my tree to my tree. Edges connected to F are going to be 13 to D, and that's about it. G, I could have 10 to D, that's better. 31 to E, that's no good. And 23 to K, that's no good. I'm going to get GD, hopefully. HK17, that's no good. And J, there's no... We've got JK15, that's no good. I'm going to get GD10. Carrying on. What is the shortest edge that connects a vertex on my... not on my tree, to my tree? Well, I could either do JK, that's currently 15, that seems to be the best from below. Are there any others? It doesn't seem to be. We could also do DC or CD, that would also be fine. Let's try that one. Yeah. JK or CD, I think I'm going to go JK. 15. Okay, that unlocks this short edge here that goes to E. So KE7. Really powerful edge, that one. So KE7. I need to find another shortest edge that connects a vertex not on my tree to my tree. Those are only the vertices that will connect B, C, and A to my tree. BE13 looks like a good contender. CD15 isn't better, so I'm going to do BE. 13. And now I can do AB5. And last but not least, CD15. So I still did CD15 in the end, despite choosing JK earlier. So I've clearly stated the order in which I selected the edges of my tree, and I've also drawn the tree to be helpful. Part D, I'm asked to state the length in miles of the minimum spanning tree. I'm going to add all of these numbers together. I'm going to get a result of 80 miles. So where do the marks come from for this question? Well, there's 3 marks for performing Prim's algorithm. Looking at the mark scheme, you get the method mark for getting the first 4 edges correct. Then an accuracy mark for getting the first 7 correct, and an accuracy mark for getting all 9 correct. Last but not least, there's an independent accuracy mark for getting part D correct. So that concludes this video, so I'll see you next time, and goodbye.